Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, minimum domino rotations for equal row. It's today's problem in the October LeetCoding challenge. Um, so we have n dominoes listed here, and each domino has two faces. One is on the upper side and the other one is on the lower side. And those values are between 1 and 6, right? So in this example, we have 6 dominoes in a row, and each of them has upper side and then lower side. And A is basically the row A is capturing the upper side of the domino, and B is capturing the lower side of the domino. And what we need to do is we need to make minimum number of rotations of dominoes so that one of the rows become equal. That means one of the rows is going to have all the values which are same, right? So a rotation of a domino means you just flip upper and lower side. So if you've seen in this example, column number 4 or fourth domino is flipped here and second domino is also flipped, right? So that's how it's going to look like, and we need to do it in minimum number of such rotations, right? So my approach here is so to do that, obviously we are not moving dominoes here and there, we're only flipping up and down. So that's why every domino, like we can call that as a column here. So every column needs to have that number we want to make it equal. So in this example, number 2 is basically there in all the columns. That's why we could make it as present in one complete row. So that means this number 2 is present in every column. If that was not the case, we couldn't have done it, right? So we need that one number which is going to be present in every column, right? So we can find that out, and to find the frequency of each of these numbers. And once we find out, we know the number, right? The number is 2 in this case, right? Now we need to figure out how many rotations are needed to bring this 2 to one of the rows. So just figure out how many of them are present in each of the rows, right? 2 is present in once, twice, thrice, 4 times in row A, and it is present 3 times in row B, right? So what does that mean? There are only 6 columns, but we got a count of 7. Actually, one of them is overlapping because of that, right? Overlapping means it appears both in row A and row B. So there is no point in rotating that. So we should be able to ignore that, right? All it means is if we look at this 4 number, we were supposed to have 6 of them in this row, right? 4 of them are there. That means there are only 2 other places where we don't have a 2, right? Which is in second column and fourth column. So if those needs the rotation. So that's why the answer has to be like 6 minus max of this 4 and 3, right? Because 4 is the max, and then we just need 2 more rotations to get it done, right? That's the approach I'm going to use. It's a greedy approach. It's an optimization problem, but it's a greedy approach. It's not that hard. Let me explain my solution. So we have n columns here. That means n dominoes, and then we want to find the frequency of each of those numbers 1 through 6. So I'm having a vector of 7. So I'm not using frequency of 0. I'm using 1 to 6, right, for convenience. I go through every domino, and then I find the frequency of each of those numbers. So whenever it is present in both of them, both rows of the column, I just count it as 1, because I just want to see in how many columns a number is present, right? So if it is present in both, I just count once. So now these frequencies, this j equal to 1 through 6, this is going to tell me which is that number, right? So whichever is equal to n is going to be the number, right? I'm going to remember the number. So if the number is something we could not find through, if it is not nothing, if we don't have the number, obviously the answer is going to be 0 here. So that's why I'm going to return -1, right? So in this case, we cannot actually do it. And what I'm going to do now is I'm going to count how many dominoes are actually in row A, how many the number is present, and how many the frequency of the number in row B. So I'm going to find both of them in both rows, how many times the number is present. So finally, as I told you, I'm going to take the max, and then n minus max of that is going to be the number of rotations needed, and this should work, right? Let me submit, and yeah, it accepted. See, it works in linear time. Obviously, the number of possible values are only 6, so that is constant. But the number of dominoes is n. If you look at here, this loop runs for exactly n number of times, and we have this is a constant number of times, and this is again n number of times. So this works in linear time, right? So yeah, obviously linear time is the lower bound for this one. But if there is still a better way of doing this one, something, tuning this one and making it faster, please let me know in the comments. All right. So please subscribe to the channel and like this video. Happy coding. Thanks for watching.